Well, here we go looking at and talking about regression, and that is, okay, so now we've been looking at single variable data, well, somewhat. Most of the data we've looked at is single variable. Now we're going to start looking more at bivariate data. Now we've already done bivariate data when we had a table of values who had rows and columns, but now we're going to look at bivariate data where we're talking about coordinates. So you see right here, I got this graph, this XY plot, which each of these little data points on here, and they're all clustered together. And we're going to start by going and doing what we've done all the time, and that's describing shape, center, spread, and outliers. So when we're doing it with a linear regression, that's what we're calling this. So linear regression means we're going to see if the data follows a linear pattern. And when we do it, we're going to describe shape, center, spread, and outliers, but we sometimes use slightly different language, but the idea is still the same. Form, direction, and strength. So strength is how close are the data points to following whatever pattern we see. So is this data following a pattern? The answer is yes, it is. It's all going up. Is it going up in any type of a curved pattern? No. Is it linear? It actually is somewhat linear. So we'd say that this is, I would say, moderate, linear. So moderate strength and linear. Now what would make it stronger? Well, if all of these data points were closer together. So if we look at another one here, that's a little slightly negative, but they're more spread out down here. So a little bit less strength. Ignore this, we'll get to this in a second. All right, this, a little bit closer together, still going positive. Now if these points were closer, I'd say it was a little bit stronger positive. Okay, and I said positive. So let me just go through here quickly some of the elements of it. So first we talk about strength. All right, so is it strong, moderate, weak, or no relationship? All right, so strong, moderate, weak, or no relationship. Is it positive or negative? Positive means as x goes up, the corresponding y values go up. So as x goes up, y goes up, so it's going up from left to right. If it's going down, it's said to have a negative relationship. All right, so strength, strong, moderate, weak, or none, positive or negative. So strong, in this case, this is moderately strong, negative, linear relationship. Linear describes then what kind of pattern we're actually seeing. All right, so linear pattern. Strong, or yeah, this is actually not too bad. Semi-strong, negative, linear relationship. And there do not appear to be any outliers. So the word outlier still stays the same. All right, when we're describing the graph, that's using words and describing a graph. And then I want to have descriptions of it numerically. All right, so numeric descriptions, and some of you may remember this from your past, may have seen it at one point in time. It's what's called Pearson's correlation coefficient. So basically what you got here is, that's what these numbers are over here. It's called the R. R is Pearson's correlation coefficient. The actual formula is, well, not necessarily an easy thing to write down and figure out. And most of the time we're not going to do anything with it other than know what it is. But the idea is, what does R tell us? So the closer R is to -1, the stronger this relationship is. This number is impossible. R can be at the very smallest, -1, and at the very largest, +1. And what that means is if it's exactly -1, that means every data point on the list, every data point on the graph is exactly on the line. And it's going down. Negative means down. If it's +1, that means every data point on the graph is exactly on the line and it's going up. So this is we're supposed to guess which one we think this is. All right, so you're like, oh, this is impossible because it can't be further below the -1. -0.98 is actually really, really strong negative, and this is not that strong. -0.88 is sort of strong. I'm going to guess it's -0.78. All right, and then I'm going to have it show. Ooh, it's -0.68. All right, so I've been doing this, forever, longer than you've been alive. And I'm still getting slightly off numbers because you're just asked to guess at this point. All right, so what I can do here is I can like even draw in what I think that line is. All right, and show the minimum. The minimum MSE is 58, and that's 66. We'll talk about what that is later, but that's actually not too bad for me just graphing one by hand. And if I draw the actual regression line, you can see what the actual regression line is. Go to new data set. So with this one, positive, it looks a little weaker than the other one. I'm going to guess 0.55, and it was 0.65 this time. All right. And I can keep going on. Ooh, there's a lot less. I'm going to say 0.34. And I'm right this time. There's just not much connection there. So if I have a completely random scatter of data, that would give me an R of 0. So let's take a look at this. So this is, if I start putting some dots on here, it starts to draw in the line of regression. All right, so 2 points. That means my line of regression exactly on those 2 points. And if over here I look, my R, Pearson correlation coefficient, is exactly -1 because every data point is exactly on that line. So they are all on these. So then if I add a third point, you can see now my R right there, Pearson correlation coefficient, is no longer -1 because every data point is no longer on the line. But as long as I have points that are staying close to that line, you can see that that R value stays pretty strong. So let's add some points like right on the line. And you see that R starts getting closer and closer, bigger and bigger to -1. All right, if I put one way out here exactly on the line, let's see what happens. Boom, it jumps way up. Put one way out here. Boom, it jumps way up. So 0.97, that's really, really strong. Throw one over here. Starts having a huge impact. Start making some points that are a little bit less on that line. So what started as a really strong negative relationship now is basically 0. All right, see how that goes? Now we'll get to what all these other are, what these other values are with coefficients and all at a later time. So then when describing this data set, obviously this one has weak to no relationship, linear or otherwise. So strength, weak to no relationship, basically no relationship. Form, there's no linear, there's no curve, there's no nothing. And there do not appear to be any potential outliers either. And then this number confirms that information. So this is our beginning point in terms of describing relationships of bivariate, or in this case, X and Y plot data. As we go along, we're going to do more in terms of how to describe the data using numbers. And those numbers are going to be what's called a least squared regression line, or basically an XY plot, where this number is one of the values, this is the other value, and then we'll eventually get to these confidence intervals for the two, but actually this is like chapter 13 or 12 right at the end of the year. This information we won't need to know, but I show you this because there will be times when certain parts are included in a problem and we have to use the others to get to the, well, you'll see when we get there. Let me make one other point though. A least squared regression line goes through the point x bar, y bar. That is, if you take all of the x coordinates and average them, take all the y coordinates over here of every data point and average them, this line goes through that point. So the mean of y is y bar, and is the mean of x on here? I don't see it. We'll eventually get to residuals, where it shows how far every data point is above and below a line. If I add a point there, you can see what happens. Over here on the way right, boop, and it shows up way over here. But that shows about how far every one of the data points is away from the line. And that's also a very important thing, but later. All right, folks, no question to answer in this video. Since it's the first time with me using this computer program in a long time, I'm just happy that I got it done. We'll see you in class.